Hello everyone, welcome to the Maruti classes. Today we are going to start next chapter of our classes mathematics, chapter number 3. That chapter is quadrilaterals. So we have to start the next chapter, quadrilaterals. So as the name implies quadrilateral, so first of all the question raised is what is quadrilateral? So quadrilateral is nothing but a type of polygon having four sides. The quadrilateral is nothing but the polygon having four sides. It may be square, maybe rectangle, maybe trapezoidal, maybe rhombus, etc. Any type of figure having four sides is called quadrilateral. So our question is if quadrilateral is a type of polygon, then what is polygon? What is polygon? So we have to firstly understand what is polygon. To understand polygon in a better way, let I am explaining you. Polygon is nothing. Our chapter is quadrilateral. Quadrilateral. Quadrilateral is the terminology is made from two words quad and lateral. Quad means four and laterals. It means sides. For simply understanding, we can understand that four sides, any figure having four sides, that is termed as the quadrilateral. So quadrilateral is nothing but a type of polygon, one of the type of polygon. So our question is, what is polygon? Polygons are also classified into many types, but in simple one line definition we can say that polygon is nothing but a curve when we start making curve without lifting up our pen, whatever the figure we have made is called polygon. Either either like this. This is closed polygon, this is open polygon. And further, as per our notebook, we can classify polygon into two types: convex polygon and concave polygon. Convex polygon and concave polygon. So here, what is convex polygon and what is concave polygon? We have to understand what is convex polygon and what is convex polygon. Here, the simple identification for convex polygon and concave polygon is that when the figure or when the polygon having all the sides less than 180 degree, then the polygon is called convex polygon. When the sides, any one side of the particular polygon or particular figure of polygon having more than 180 degree, then that polygon is called as concave polygon. If any one side is more than 180 degree, then that polygon is known as concave polygon, just like this is more than 180 degree. So this figure will be the concave polygon. We will see more examples of the convex and concave polygon in the further pages of your chapter, but you have to remember the one line definition of 3 to 4 terminologies as I am said you. Like I am explaining again. Firstly, I am explaining you what is quadrilateral. Then I am explaining you what is polygon. Further, I am explaining you what is convex polygon and what is concave polygon. You have to remember all these terminologies by a simple definition. Quadrilateral is nothing but a type of polygon, a polygon having four sides. its example may be square, maybe rectangle, maybe rhombus, whatever. But the main ethic of these of quadrilateral is it is must to having the four sides. Polygon, what is polygon? Polygon is nothing but a curve, a simple curve having without lifting, without lifting, without lifting, then whatever the figure is made is called polygon. So polygon further classified into convex polygon and concave polygon. The term convex polygon is nothing but less than 180 degree, having any side shouldn't be more than 180 degree. Concave, if any one side, if any one side is more than 180 degree, then this figure will be termed as the concave polygon. It is as simple to understand the definitions. Okay, let go to your book page for further classification as given in your book. Look at to the page number 1 of your chapter number 3, convex polygon, convex and concave polygon. Here they were made some curves. Look at here, this curve is the closed curve, this one is also closed, these are the closed curves that are polygon. So firstly they were tried to explain to you what is polygon and what is not polygon. If these curve cut across each other, then this figure will not be called as polygon. And if curve either regular or irregular, they were called to be the polygon, but their key word is that they can't intersect with each other, then this will called as polygon. Otherwise they were not called as polygon. Here polygon are classified into convex polygon and concave polygon. They were given us some examples of convex polygon and concave polygon. Look at here, the convex polygon. Here you can see that no any angle were more than 180 degree of this figure. In all of this figure, no any angle will be seen as more than 180 degree. That's why this figure were termed as the convex polygon. But here as we can observe that here more than one angles or one angle is more than 180 degree. Here look at here, if we see that uh, we can observe by we can observe this figure on the blank sheet. As for more clarification, look at here, look at the figure. This one is figure, this figure is given in your book and say this is the example of concave polygon. How this will be the example of concave polygon? Here it is less than 180 degree, here it is, it may be 180 degree or less than 180 degree, but here we can observe that it is more than 180 degree. Here we can observe that it is more than 180 degree. So this will become concave polygon. One more example which is mentioned in your book. Look at here, this is more than 180 degree. 180 degree simply means this one is the 180 degree, the flat surface. This will be, this is your 180 degree figure, but it is more than 180 degree. Further example like this, here you can observe that in this figure it is also more than 180 degree. As further we are going move forward to the next example, here we can also observe that it is also more than 180 degree. So they were given us simple examples to clarify our concepts, that for the clear identification of that which particular figure is convex and which particular figure is concave polygon. Further we are moving forward, we can observe that the polygon are further classified into the regular polygon and irregular polygon. So what is a regular polygon and what is irregular polygon? I am giving you one line definition for regular polygon is that any polygon having sides and angles are equal. Any polygon or any figure having sides and angles are equal, then this will called as the regular polygon. And if the any one side and any one angle is not equal, not equal with as compared to the other angle or other side, then this will called termed as the irregular polygon. I am using two terms here. You have to notice what I am saying here. Here I am using the terms in case of regular polygon and irregular polygon having sides and angles are equal, having sides and angles are not equal. In case of regular polygon, here we can see the examples like square, yes, like rectangle, no. Rectangle is not the example of regular polygon. Having examples like hexagon, yes. So here we can simply classify that which one is the regular and which one is the irregular polygon. Yeah, no doubt, angles are same. All angles are 90 degree, but the sides are not same. Here angles are same and sides are also same. So this is the example of regular polygon. It is as simple to differentiate between the regular and irregular polygon. It is not much too difficult to understand that. Here we can see that some examples they were also mentioned in their notebook. They look like look at that here. This is the equilateral triangle. Equilateral triangle. This term it simply means equilateral triangle, equal sides. Equilateral simply means equal sides and equal angles. Here the angle 60 degree, 60 degree, 60 degree. Here the sides is a is equal to a is equal to a, 3a. When we see the perimeter of this equilateral triangle is 3a. Here the another example is the square. This is the pentagon. This is the hexagon. These all are the example of the regular polygon. But when we see here the when we see in the irregular polygon, the example is rectangle, hexagon having one side having two sides is more than another sides. Look at this heart-like structure. Here also we can observe that this is the example of irregular polygon. Look at the triangle. Here one side is here no any side is equal to another sides. This is the of course example of right angle triangle, but not the example of the regular polygon. So you have to notice two terms, angle and sides must be equal for that. Now moving forward to your exercise, we have to classify them. Which one is the example of convex polygon and which one is the example of concave polygon? By the simple observing, we can say that in our example number one is concave polygon because this angle is more than 180 degree. Here no any angle is look more than 180 degree. Here not more than 180 degree, not more than 180. So this is the example of convex, concave, convex. Here in the figure of circle, it is not possible to make circle if the angle is more than 180 degrees. So this is the best example of convex. This one here, look at here also we can see that this is more than 180 degree. Here I am making a figure in the another page for better classification. Then you can identify the star here. Here you can observe that, look at this, and further we can see that, look at this. So it is more than 180 degrees, so it is not the example of convex, it is a concave polygon. It is an concave polygon. Now further examples, we can see that here also it is more than 180 degree, it is less than 180, so it is convex. It is more than 180 degree, it is concave. It is less than 180 degree, so it is convex. It is as simple. Now classify, acha, oh, okay, and this is the term of this. Okay, so yes, simple curve, which one is the simple curve? This is the simple curve, this is the simple curve. Okay, you have five options. I am giving just two example, convex and concave, but you have five options. So this one is the example of concave. Second one is the example of convex. Third one is the example of simple closed curve. No, yes, simple curve, simple closed curve. And polygon, yes, all are polygon except figure number 4 and figure number 8. And yes, all are understood by us. Now further, what is a regular polygon? State the name of regular polygon of 3 side, 4 side, 6 side. 6 side is hexagon, 4 side is quadrilateral, 3 side is triangle. Triangle having 3 equal sides, that means equilateral triangle. Quadrilateral, square, 6 side hexagon having all sides equal and all angles are equal. That is just simple. Now moving forward, here we can observe that sum of measure of exterior angle of a polygon. Firstly, we have to understand what is exterior angle and what is interior angle. Exterior means the outer angle and interiors mean the inner angle. Firstly, I am giving you some formula and the notation of this one here. Here we have two terminologies, exterior angle and exterior angle and yes, interior angle. Interior angle. To understand this, I am giving you an example. I am giving you by a figure. Look at here. Just like this one is your figure. I'm using rubber to correct some mistake. Yeah, no, fine. Yeah, like this. Here, this is the closed figure having many sides. I am not counting how many sides. Here we can say that this one is the angle, this one is your angle, this one is also your angle, this one is also your angle. Understand, this one is angle, this one is angle, this one is your angle, this one is also your angle, this one here, these all are angles. Here angle A, B, C, D, E and F. Here A dash, A dash, B dash, C dash, D dash, E dash. So here exterior angle is A, B, C, D, E, F Interior angle is A dash, B dash, C dash, D dash, E dash, etc. Now we have to understand that uh, how to calculate exterior angle and how to calculate interior angle. I am giving you some formula for exterior angle to calculate exterior angle. Exterior angle here. Here you can see that this one is rotating like this. So this is equal to 360 degree. Hence, to calculate exterior angle, we have a simple formula 360 degree divided by number of sides. Here number of sides is 1, 2, 3, 4, 5, 6. 6 sides. So here we are using here A, B, C, D, E and F. Okay. So here the exterior angle will be equals to, for a regular polygon. In case of regular polygon, because in regular polygon sides and angles are equal. So here exterior angle will be equal to 360 by n and 360 divided by 6, and so the ultimately the exterior angle will be equal to 60 degree. So your formula for exterior angle is 360 by n. You have to note down this formula. And further, for interior angle, to calculation of interior angle, in case of regular polygon, here the formula will be equals to n minus 2 into 180 degree. Here n is nothing but the number of sides. Here how many sides? 1, 2, 3, 4, 5, 6. So 6 minus 2, 4 into 180 degree. So the sum of interior angle will be equal to this 18 cross 4. What will be the result? 72. 72. Is I am right? 18 cross 4. That is 32. 3, 4, 1 ja 4. What will be the result? 7. So 72, 720 degree interior angles. Sum of interior angles. Understand? Sum of interior angle will be equal to 720 degree. So what is the value of each interior angle? The value of each interior angle to calculate, we have to divide 720 divided by 6 because we have 6 sides. So now the result will be 120 degree. 120 into 6. 120 degree will be the result. It is as simple. Now in your notebook we have some example in particular topic. We have to see the examples. Okay, listen here. Look at sum of measures of exterior angle of a polygon. Here, look at to your notebook what they were mentioned here. Sum of measure of exterior angle of the polygon. As I am explained you recently, look at here. They were adding all the exterior angle which is equal to 360 degree. What does it simply means? I am giving you the diagrammatic example of that. That after one's complete rotation, it is equal to 360 degree. That's why by adding all these, they will sum up with 360 degree. So they were mentioned this year. Now, for example, what find the measure of x here? They have to calculate the value of x. So what they did here? What they did here? They add all the exterior angle and this will become equal to 360 degree. Look at here, I am giving you a diagrammatic format of this particular question. So what is your question here is, in the example number 1, what they have tried to ask in particular question. Here this one is the x degree, this is 90 degree, this is 50 degree, this is 110 degree. Now here sum of exterior angle is equal to 360 degree, as I am said you earlier in the previous page. So according to this formula, we have to add all these terms and equate this equal to 360 degree. Now we are able to calculate the value of x at it is given, at it is equal to 110 degree by subtracting 360 by the sum of all this. So it is as simple. They were try to explain us in example, in the way of example in your notebook. Now further they were trying to explain you the interior angle, what is the sum of measure of sorry, they were questioning with the exterior angle. Firstly, regular hexagon, what is the sum of the measure of the exterior angle x y z p q r, is this one all are equal? If yes, then why they were equal? Because they were in the regular hexagon, their angles and sides are equal. So what is the measure of each exterior angle and interior angle? I am just explaining you and giving you the examples and writing the examples which is exactly the same of this particular question. Repeat this activity for the cases of a regular octagon and a regular pentagon. In case of regular octagon, what we have to do? We have to solve this. Look at here, nothing to do. For a regular octagon which is regular, what we have to do? For exterior angle, what will be the value of exterior angle? 360 by 8. This is the value of each exterior angle. For interior angle, what we have to do? N minus 2 into 180 degree. It simply means n is equals to 8. 8 minus 2 into 360 degree. This is the sum of interior angle. 6 into 360. Sorry, 6 into 180. This is 180. 6 into 180 degree. This is the interior angle. 6 into 180. Now this by cutting with what 4 and 5, 45 degree. This is your exterior angle and here interior angle, sum of interior angle. So one side of interior angle, this is the sum of interior angle. So each angle of interior will be equals to 6 into 180 divided by 8. So now what will be the result? 2 3 times, 2 to 4 times, 4 to 1 times, 4 4 cross 4 and 5. So 45 cross 3, 135 degree. Understand? This is the ultimate result of this question. Here what they were asked in the question, look at your notebook. What is the measure of each exterior angle and interior angle? Yes, simply it is 45 degree and it is 135 degree for octagon. For a regular 20gon, so in case of 20gon, what we have to do? In the place of 8 we have to place 20 and the remaining procedure of solving is same. It is as simple. Now moving forward, example number 2, find the number of sides of the regular polygon whose each exterior angle has a measure of 45 degree. Simple, 360 by n degree. 360 divided by one side, which is equal to n. As I am explained you by the help of formula, they were asked same question in your example. What I have explained, your exterior angle is equal to 360 by n is the number of sides. So they were asked what is the number of sides here, and they have to calculate, and they were mentioning the question exterior angle as 45 degree. So n is will be equal to 360 by 45 degree. So your ultimate result will be equal to n is equals to, you have to divide this like 15 cross 3, 15 cross 2 and 4, now 8. So n equal to here 8. This is your answer. It is a simple. Now moving forward to your exercise. Now this one is the very simple example. You have to add 125 plus x. 250 plus x is equal to 360. So your answer will be equal to 110. Now here this one is 90 degree, this one is 90 degree, 70 and 60 degree, and this is unknown. So one equation, one unknown, you have to put the values as per the format and get the answer. How? What will be the answer? 70 plus 60 plus 90 plus 90 plus x is equal to 360. Now it is as simple as to calculate the value of x. Now further, find the measure of exterior angle of a regular polygon of the 9 sides and the 15 side. As this one is I am already talk you explain you in the above example. What you have to do here, 360 divided by 9 and 360 divided by 15 to calculate exterior angle. For interior, no, here only exterior angle were asked, no need to calculate interior angle. So now further moving forward, how many sides does a regular polygon have if the measure of the exterior angle is 24 degree? If the exterior angle is 24 degree, then you have to calculate the number of sides. You have to divide 360 by 24, then you will get the number of sides. Now further question number 4, how many sides does a regular polygon have if each of the interior angle is 165? You have to simply divide this one. No need to divide. Here in the example number 4, what you have to do, sum of interior angles, they were given each side of interior angle. Let us solve example number 4 for your better clarification of interior angles. Look at here, I am explaining you. They were asked in example number 4, if interior each of interior angle is equal to 165 degree, then your question here is, then how many sides of the regular polygon? They were asked, and they were asked here this. Now we have to use simple our formula, sum of interior angles, which is equals to n minus 2 into 180 degree. They want this value. Now sum of interior angles, we have to calculate sum of interior angle. This one is our formula, and each of interior angle here, this one. Here interior angle is 165 degree. Now here what we have to do here given interior angle, don't use this formula. You have a more simple way to solve this here is if interior angle is given as 165 degree. If interior angle is given as 165 degree, it simply means exterior angle will be equal to 180 minus 165, which is equal to 15 degree, which is equals to 15 degree. Exterior angle will be equal to 15 degree. Now to calculate n number of sides, we have a simple option of exterior angle. Exterior angle will be equal to calculate number of side, we have the formula 360 by angle 360 by n. If our exterior angle is 15 degrees, so 15 is equal to 360 by n. Now n will be equal to 360 divided by 15, so n will be equal to 1 time, 2 time and 4 time, 24. This is our answer. Have you understand what I'm trying to explain? I am explaining you again once more. Look at here. Here you have given interior angle 165 degree. You have to calculate number of sides. So what we are doing here, what we have to done to simplify it, we are convert interior angle into exterior angle. First step 1. Here we are subtracting 165 with 180 and getting the answer 15 degree as the exterior angle. Now for we know that exterior angle is equal to 360 by n. This is equal to 15 degree. So n will be equal to 360 by 15. That's why the value of n will be equals to this one. Here we are able to calculate this. It is as simple. We have to know the sequence to solve any question. If you are knowing the sequence, then it is very simple for you to understand the solution. Now here further moving to the question number 5, is it is possible to have a regular polygon with measure of each angle equal to 22 degree? Is it possible having a regular polygon with each angle equal to 20 degree? You have to simply divide this one, and if the result come up in decimal format, then it is not possible. So this is the simple way to solve this. Can it be an interior angle of a regular polygon? Why? What is the minimum interior angle possible for a regular polygon? What is the minimum interior angle possible in a regular polygon? Think how you will solve this question. You have to just think that how you will solve this. They were asking you the concept. They were asking the simple concept. Have you clear what they were trying to ask you? Look at here. As we are studied that interior angle will be equals to sum of interior angle equal to n minus 2 into 180 degree, or we can say that one angle, one interior, each angle of interior angle to calculate, we have dividing this sum of interior angle by the number of sides. So what will be the smallest angle, smallest minimum interior angle, what will be the value of minimum interior angle possible for the regular polygon? So here, the for regular polygon, we have to firstly take a diagrammatic example for better classification. Look at here. Here for regular polygon, we have earlier seen some examples like this one is the for equilateral triangle, square, hexagon, etc. Pentagon, octagon, whatever. So the smallest one is triangle, three sides. We are not able to make a polygon by adding two sides. We need three sides. So triangle is the figure which is the minimum polygon, minimum whatever. What is your question? Look at to your question. Yes, what is the minimum interior angle possible for a regular polygon? That regular polygon is your nothing but a triangle, and for equilateral triangle the angle will be equal to 60 degree, as we know that, but we need to prove that one. We need to prove it. So how we can prove here? It is a simple here n minus 2 into 180 degree divided by n. Here n is equals to 3 into 180 divided by 3. So each of your interior angle will be equal to 180 divided by 3, which is equal to 60 degree. This is your answer of this particular question. Now how you will frame the wait. Yes, look at here. This is the minimum value for interior angle, three sides. We can't able to make interior angle by two sides, sorry, regular polygon by two sides, so we need three sides. So this one is the equilateral triangle. Here we know that the formula of interior angle, calculation of interior angle, n minus 2 into 180 divided by n. So here the your value is 60 degree. This one is your answer. The minimum you need 60 degree as how you will frame the answer of particular question I am explaining you once again. The minimum interior angle possible for a regular polygon is 60 degree, because we need three sides of a polygon to make a regular polygon, and these three sides will be called as triangle and nothing but the equilateral triangle. Now further the question number B, what is the maximum exterior angle possible for a regular polygon? Now what you have to read here, maximum the first question is minimum interior angle possible, and second one maximum exterior angle possible for a regular polygon. So how you will solve this one? I am explaining you the exterior angle formula 360 by n. Since a regular polygon must have three sides, so exterior angle will be equals to, if in any figure, I'm explaining you in the diagrammatic format for better clarification. If you will made this one as minimum angle, so minimum interior angle, that means maximum exterior angle. If this one is the minimum interior angle, then that one is your maximum exterior angle, and sum will be equal to 360. So here, no, look at here. If this one is your 60 degree, then your exterior angle will be equals to this one. You can like this and like this. If this one is 60 degree, then this one is equals to 120 degree. Here like this, here like this. Okay, so how we can write this in a format, in such a format, this will understand in the diagrammatic form. In the form of formula, we can write this one is like this: 360 divided by 3, because this one is a equilateral triangle, so here the result will be equal to 120 degree. This is your exterior angle. It is a simple. Now moving forward, now what chapter name is quadrilateral. Now here name of the chapter quadrilateral, first time used in your book, kind of quadrilateral. So I am already explained you quadrilateral is nothing but a polygon having four sides. So trapezium is also an example of quadrilateral. These are the trapezium, these are not trapezium. These all are trapezium. So the trapezium is nothing but two sides are parallel. Having two sides parallel are called trapezium. Here no any two sides are parallel, so they were not a trapezium. Take identical cut out of the congruent triangle 3, 4, 5, arrange them as shown here. 3, 4 and 5, the triplet. Now further you get a trapezium. What are the parallel sides here? Now kite is a special type of quadrilateral. The sides of the same marking in each figure are equal. In case of kite, look at here, two sides are equal. Two sides are equal. For example, AB equal to AD and BC is equal to CD. You need two sides equal. A kite has four sides in a quadrilateral. They were exactly two distinct consecutive pair of sides of equal length. They were given you some examples to uh, for your more clarification. You need to read in your home. Now further moving to the parallelogram. What is parallelogram? What we have learned here, firstly trapezium. After the trapezium, what we have learned, after trapezium, for kite, what is kite? Two sides are equal. Then further moving to the parallelogram, as per the name implies here, the parallel lines, two sides are parallel and further two sides are parallel. This is the example of parallelogram. In trapezium only two sides are parallel, but here four sides are parallel. So rhombus is also parallelogram, square is also parallelogram. Now look at to the exercise portion. Just look to the example. They were given us the example. Firstly, see what they were trying to explain us in the example. Take two identical set of square with angles 30, 60, 90 and place them adjacent to form a parallelogram to show here. Does this help you to verify the above property? 1, 2, 3, 4. Looking at this angle, angle 1 is equal to angle 2, angle 3 is equal to angle 4. Since in triangle ABC, angle 1 is equal to angle 2 and angle 3 is equal to angle 4. AC is common by area, side, area, congruency condition. Triangle ABC is equivalent to triangle CDA. This gives AB is equal to DC and DC is equals to AD. Now going to your exercise. All the simple examples they were right here. Yeah. Look at to the exercise 3.3. Now here, given a parallelogram ABCD, complete each statement along with the definition or property used. Here they were asked which is equal to AD. In the question number 1, which is equals to AD. So here AD is equal to BC. Angle DCB is equals to angle DAB. How? Side angle side, side angle side, side angle side. By this property we can say that DAB is equal to DCB, OC is equal to OA. Here this one equal because of parallelogram. This is the rhombus, that's why OC is equal to OA. MDAB DAB plus MCDA AB. Look at to the middle term. Look at to the middle term AD. Here A and D are used, so here B and C we need to use. So A, B, C and D, C, B. So like this. It is as simple. Now moving forward, consider the following parallelogram. What is the value of unknown x, y, z? We have to calculate the value of x, y, z. So here y is equals to, what will be the value here? Two sides are equal. Here x is equals to z. Here y is equals to 100. So 2 times of z. Let us solve in the fresh page for your better clarification. What they were trying to explain here is, now here look at this. This is equals to 100 degree. This is y, this is x, and this is z. Now here in case of parallelogram, two sides are equal. Here two sides are equal, two angles are also equal. So y is equals to 100 degree, z is equal to angle z is equal to angle x. So here by adding all this we can say that x plus y plus z plus 100 degree is equal to 360 degree. Or we can say that x plus z is equals to 360 minus 100 minus y is equal to 100. Or 2x is equals to 160 degree. Or we can say that x is equals to 80 degree. X is equals to z is equals to 80 degree. So what they were asked here is the value of x, y and z. So here we are able to calculate. Now next question, what they were given here. Oh, sorry. Yeah, look at here. Here I am giving you the diagrammatic format of this particular question. X, y, z. Here in parallelogram, y is equal to 100 degree. Angle z is equal to angle x. So x plus y plus z plus 100 equal to 360. So x plus z is equal to 360 minus 100 minus y, the value of y. This is the value of y. So 2x is equal to 160 and x is equal to 80 degree. This is your answer. Now further question here. These all are the same, are solved in the similar way. They are all simple questions. Now moving forward to question number 3. Can a quadrilateral A, B, C, D be a parallelogram? angle D plus angle B is equal to 180 degree. AB is equal to DC is equal to 8 centimeter. And further, these all are the simple questions you have to need to solve at once in your home, and the further class will be carried out on the next day to solve the exercise of this particular question. So guys, today's class is ended here. Further questions were solved in the next class. Thank you everyone.